Hello everyone, welcome to this 10th video about Golang. And today we're going to look at if and else statements as promised in the last video. So we're now comfortable with the concept of logical operators as well as comparison operators. So let's here in just one sentence. And so now we know how to combine Boolean values together into more complex and we could say expressions. Actually, we can now call these complex expressions, we're going to refer to them as conditions. So, and we say that a condition is true if this complex expression, that can also be just one Boolean value, is true. Whereas we say that it is false, or that it is not satisfied if evaluating it yields false as a Boolean value. So now that we have that, sometimes in our programs we want to react in a certain way if a certain condition is satisfied or not. So for example, imagine that you have a program where they're going to ask you to compute a factorial. So of course, the classical integer factorial, and here we're ignoring various extrapolations that can be done, does not make sense for example, a negative number or for a number that is not an integer. And so for this reason, imagine that we make a function to make a factorial and they pass, for example, a negative integer inside of it. Then we might want, for example, to check if that value is actually positive. And if it's negative, we're going to maybe return an error value. Or for example, imagine that you have a program which checks your name, and maybe if your name starts with an A, it's going to be a message, but you want to be a different message if your name starts with a B. So how can we do this? Actually, this is not realistic at all, but it's just an example. But how can you do this? This is done via if statements. So an if statement in a Golang program basically says, okay, if and the general syntax is if condition, then code. And usually the code inside the curly braces is placed in a new line. So let's make an example. Let's make a variable a equal to 5. So let's suppose that we want to write a program that prints equal to 5 if a is equal to 5, and else it says not equal to 5. So to check, to do this, we're going to say if a is equal to 5, using the operators we introduced in the last video, equals. Well, then we're going to say println a is equal to 5. So let's see. Oops, I think I forgot a quote. Yes, I did. Okay. So let's try and run this. As you can see, we get a is equal to 5. But now, for example, what if instead of 5 we augment it and we put it equal to 8? What happens? Let's see. We get nothing because the line of code didn't run because this condition was not met. So what if statement does is, okay, if this condition here is met, then run the code inside. If not, just skip it. So this is why nothing run. Now let's, for example, suppose that now we want to print another message if a is not equal to 5. So we're going to say a way could be if a not equal to 5. So we're going to make another if statement and say, okay, println a is not equal to 5, for example. And so if we now rerun the program, we're going to see that a is not equal to 5. So actually, in a way, we achieved our goal. But this is not a very elegant way to do it. Why? Well, because the program checks the condition twice. So it basically checks, okay, is a equal to 5? Then it goes here and then say, okay, is a different than 5? Well, in actuality, the program already knows if a is not equal to 5 when it checks if it's equal to 5, trivially. So how can we basically spare this other check? And how can you also write the code in a more compact way? Well, we can use the else keyword. So right after our if statement here, if a is equal to 5, then we can say else, and that meaning if that condition is not satisfied, then we can just print a is not equal to 5. And we will see that the program will have the exact same it will function in the exact same way, as you can see. And this is a better way to write it. So now we have learned how to control the program based on some conditions. So we can basically say, okay, if a condition is true, then do this. And if that condition is not true, so else, we can do that. But now sometimes we want to check multiple conditions. So for example, we want to say a is equal to 5 is a is equal to 5. But maybe we want to say a is negative if it's less than 0, a is positive if it's greater than 0. Then how can we do that? In this case, we will use another keyword, and that is the else if keyword. So it just means, okay, if a is not equal to 5, then if that is not equal to 5, but it might be something else, then run this other line of code. Now we're going to give the general syntax for that expression, and that is else if, and then after we just put our condition. So in this case, for example, let's say else if a is less than 0. Then if a is less than 0, we want to print out a is less than 0. And then we can say else if a is greater than 0. Then we can just say a is greater than 0. And maybe lastly, we want to say if a is equal to 0, we want to say a is 0. But in this case, notice that we have already spanned all of the integers because we covered all positive integers, all negative integers. Then here we have a case for 5, and the last case that basically is possible is just 0. So we could say else if a is equal to 0 and then run the code, but we can write it more elegantly as just else, and we can write funct print line a is equal to 0. So let's try to run our code now, and let's see what we get. We get a is greater than 0. Because, of course, 8 is greater than 0. But now, what if, for example, we decrement it, and we set it equal to -4. Let's see what happens. We got a is less than 0, as expected. And now let's try and, for example, augment this value. So maybe to 0. So maybe to 0, let's see what happens. We got a is equal to 0, as expected. So this is basically how else, if else and else if statements work. So it's just a way to control and react in a certain way based on certain conditions. And now another important thing that you might want to know is that, well, inside an if statement you can actually nest other if statements. So you might say, okay, if a is equal to 5, then we might declare another variable that could be b, and we can set it equal to 2 for now. Let's set this equal to 5 again. So inside the case for which a is equal to 5, we can actually nest another if statement. So we're going to say if, for example, b is equal to 2, then we're going to let's remove this line here. We're going to print out funct print line a is equal to 5 and b is equal to 2. And we can also include an else inside it, and we can say else. We're going to just say a is equal to 5. So let's see what happens here. If we run it, we get a is equal to 5 and b is equal to 2. Because basically what happened with nested if statements, what happens is, okay, we go inside the first if statement. Then, as usual, this condition, for example, is true. So as a Boolean value, this expression is true. And then we go inside because that is true. If it was not true, we would have skipped it. But since it's true, we are now inside here. And here we're confronted with another if statement. If else block basically, and now we check if this condition is true. Since this condition is true because b is equal to 2, then we go inside here and this is what we print. If b was not true, for example, if it was equal to 6, for example, then we will not execute this code and we would go inside the else block. In fact, let's see what happens if that is the case, and we get a is equal to 5 and nothing else, because of course b was not equal to 2, and so we have skipped this else statement. So with this said, you now know how to write if-else blocks, and also use if, else, and else if inside Golang, and you also know how to write nested if statements. In the next video, we're going to see another way to react based on some conditions inside a Golang program, and that is using what is known as switch statements.